today's session, dimensional analysis. Okay, important to realise that it only makes sense to add the same sort of quantities. E.g., you can add one area to another area to make a total area, but you can't add, for instance, area to temperature or time to area. You can only add or subtract quantities that have the same dimensions. Right? So we can come across this powerful analysis method called dimensional analysis. Starts from 5 fundamental dimensions. So what that means is the dimension of mass is m. So any mass has dimensions m. Dimension of length, L, time t, temperature K, and electrical current I. Other quantities like pressure, volume, and so on are made up of multiples of these, like a formula. Okay? So all other mechanical quantities be expressed in terms of powers of these 5 quantities. So for instance, the fundamental dimensions, or the units of velocity are meters per second. Okay? The units of acceleration are meters per second squared. And the units of force is mass times acceleration. Yeah? So we know that the units of velocity meters per second, so the units, or a unit of velocity, meters per second. Meters as a length, seconds as time, so the dimensions of velocity are L over t, or Lt to the minus 1. Remember the laws of indices. This is one very good reason. It will give you a good reason why we've done that stuff on laws of indices in the first week, because you needed it here and in other places on the course. So that's t to the 1 under there. So it comes up to the top line and becomes t to the minus 1. Change of sign. That's L times t to the minus 1. So the 2 ways to write it are like that or like that. Yeah. That's not wrong, but that's the standard way to do it in dimensional analysis. Lt to the minus 1. Similarly, acceleration has units of meters per second squared. So its dimensions are, again, the meters as a length, and seconds is time, t to the power of 2, time squared. So the units of the dimensions of acceleration is length over t squared, or Lt to the minus 2. So where that was a minus 1 up there, this comes up top, becomes a minus 2, according to the laws of indices. Yeah. What about force? Well, force is mass times acceleration. We worked out what acceleration was, Lt to the minus 2. Mass is m. Therefore, the dimensions of force must be mass times length times time to the minus 2. So do you see how all those other quantities are going to have dimensions that can be derived from those 5 base dimensions of mass, length, time, temperature, and electrical current? Yep. Right, on this next page, there's a table with some of the common quantities that we're going to come across in the course. Okay, what their units, these are the SI units of those quantities, and these are what the dimensions are. When I finish walking in front of it, I suggest you take a picture of that slide because you're going to need it later. So area is meters times meters, or meters squared. It has length to the power 2. Volume is meters cubed, length to the power 3. Velocity we did, LT to the minus 1. Okay, got pressure here, newtons, which is a force per meter squared. Force is MLT minus 2. ML to the minus 1, T to the minus 2. They're all made up from those 5 base quantities, the base dimensions that were on that first page. What they want from that? I wouldn't suggest you copy it all down because it will be all down. Alright, I've got another one for you to take a picture of as well. Right, so solving problems using dimensional analysis and the units of quantities. Okay, possible to use dimensional analysis to solve problems involving different dimensions and units. So you can treat dimensions as though they're variables in a formula, and you can cancel various dimensions out to end up with the final dimensions of the final quality you're looking for. For example, how many seconds are there in one day? Well, first of all, there's 24 hours in one day. Yeah. Secondly, there's 60 minutes in an hour, so we multiply that by 60 minutes over 1 hour. And then there's 60 seconds in 1 minute, so we multiply by 60 over 1. Looking at that in mathematically, and I know this is an easy example, you don't really need to do it, but the hours cancel out, the minutes cancel out. Yeah. It's just the units that are cancelling out here, not the numbers. Okay, so we've got 24 over 1, 60 over 1, 60 over 1. The answer is 24 times 60 times 60. We've got seconds on the top and day on the bottom. There is 86400 seconds per day. Yeah? Because they're the only ones that haven't cancelled out, is them two. So we said, how many seconds are there in one day? And we've ended up units of seconds per day. All right? Anyone struggling still at all? So, right, a flange has 16 holes. Yeah. Each hole requiring 1 volt, and each bolt requiring 2 washers. Use dimensional analysis to determine the number of washers required to make off 2 flange joints. Anyone who don't know what a flange is, Pete will tell you. Explain to Abdullah what a flange is. 'Cause So if you've got a pipe, yeah, the flange is on the end of one pipe and the other pipe, yeah, and then you have holes through them, and you bolt those two together to join the two pipes up. All right. So looking that way, the flange looks like this. There's the pipe, and there's all the bolts that hold it together. Yeah. All right. So where are we going to start with this problem? Yeah. Can we do it? Is there a way we can look at it in the same way as I did with the R's and 16 holes per what? Per flange, yeah. So one thing about that is actually that's how many washers. Let's make that bolts. Same thing, yeah, because each hole has a bolt. Yeah. 16 bolts of flange. How do we get the washers in there? Two washers. Is it two washers per flange, or is it two washers per something else? Per bolt. One bolt. Yeah. What's the other thing we got in? Times two flanges. Because the question says make off two flanges. Yeah. Just I've kept it over one, so all of them are like fractions. Okay. And then we look at what we can cancel out. So we can cancel out flange and flange, bolt and bolt. Yeah. What units do we end up with? The only thing left is washers. So it's equal 16 times 2 times 2 washers equals 64 washers. Yeah. No, I mean you can look at the question, but if it's complex and there's lots of unit changes, like from metric to imperial or back again, with money and things, then that you can get in a muddle. So if you can write it all out and see what cancels out, it can make the problem easier. If that was 2 washers per 2 bolts, then that bit in the middle there would be just 1. Yeah. Well, you can end up with more than 1 on the bottom. Yeah. 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 All right. Yeah. So what you can also have then in these problems. You all right with that, Abdullah? See that? Yeah. So we've got left with 16 there, 2 there, and 2 there. 16 times 2 times 6. All right. Right. On the next page, what you're also going to come across in these type of problems is where you need to convert between different units. So, like we used 1 hour is 60 minutes, 1 minute is 60 seconds. 1 ton is 2,000 pounds. Yep. That is imperial ton. Metric ton is TUNNE. Yep. 1,000 kilograms. Yep. Yeah, I think I've got that one on there somewhere, haven't I? No, I haven't. Yeah, take a picture of that one as well, yeah. 1 pound is 16 ounces, a mile is 5,280 feet. You'll get that table in your assignment, okay? But if you haven't got the conversion factor on there you need, you can easily find them on the internet anyway. Yep. Okay, so you're probably going to want that one in a little while too. All right. So, further problems to solve using dimensional analysis. I'll get you have a go at this one. Small generating set uses on average half a litre of fuel every hour. Using dimensional analysis, calculate the following. The time between tank refills if the fuel tank holds 6.5 gallons of fuel, and the cost of fuel for 1 week if the fuel is £1.25 a litre, and the generator runs for 8 hours per day and runs for 6 days a week. There's a two-part question. Time it takes to empty the tank of fuel, time between refills if you like, and the cost of running the generator for a week. Anyone else get anything different to around about 59 hours? If we look at that, it says time between tank refills. So what we're doing is for A, we're looking for how many hours will it run per tank. That's what units we kind of think we're going to end up as. How many hours per tank? Yeah. So if we look at it uses 0.5 litres of fuel per 1 hour. Yeah. I got this up the bloody other way on my examples. Let's just start it again. We got 6.5 gallons in 1 tank. That's how much fuel we got. Yeah. We've got our tank in gallons, but our usage is in litres. So we need to convert from gallons to litres. So we got so that's multiplied by 4.546 litres per 1 gallon. And it will run for 1 hour on half a litre of fuel. Yep. That's all taken from the question. Well, that isn't. That's from the question. 6.5 gallons per tank. There's 4.546 litres in a gallon, so we're converting those gallons there into litres, and then we're saying every hour we'll use half a litre. And we can go along there and say the gallons cancel out. Yeah. The litres cancel out. And so our answer is 6.5 times 4.546 times 1 over 0.5. Yeah. And the units are R's per tank. Because they're the units left. Tank R. Yeah. So that works out to somewhere around about 59. R's per tank. Yeah. And that's what you would expect from what kind of the question's asking, is how many R's will it go for per tank? And going through this process of dimensional or unit analysis, we can prove that that's the case. Yeah. What about B? Well, we've said, the question says, the generator runs for 6 days every week. 6 days per week. What units do you think we're looking for in that second question? Cost of fuel for 1 week. We're looking for how much, what's the cost of fuel for 1 week? So what are the final dimensions going to be? They're going to be a cost, pounds, yeah, per week. Pounds per week. See that or not? So that's what we're expecting to come out as. So we'll check it now. It runs for 6 days a week. It runs for 8 hours every day. Yeah. So those two, if we started the cancellation now, it would give us how many hours per week? 6 times 8 hours per week. Yeah. So that's how far we got so far. Then the question says it uses 0.5 litres per 1 hour. Yeah. So again, cancelling up to where we got to now, that cancels and that cancels. So it's 6 times 8 times a half litres per week are the dimensions that are left now. Yeah. And then lastly, the fuel costs £1.25 per 1 litre. And the litres cancel there, litre cancel there. So we've got 6 times 8, 6 8s are 48, times half, 24, times 1.25, 30, and the units left are pounds per week. Yeah. We've got pounds there, we've got week there. Yeah. Okay. Now, in this next example, the typo has the bloke changing name. Starts off by saying Bill, and then his name changed to Leonard. But he must be aboard Leonard, because he's working in the nut and bolt factory for the last 30 years, packing 10 nuts and bolts into a plastic bag and sealing them up. Every hour Leonard produces 254 bags of nuts and bolts. He works 5 days a week and 8 hours a day, and he's paid every 2 weeks. Wade packet is £840.43. That sounds like a lot of money for packing nuts and bolts to me. I don't know if that meets the current minimum wage. How many packs of nuts and bolts will Leonard have to produce in order to earn his first £1 million? So have a go, see if you can make a start on that one, and see how many packs of nuts and bolts is worth £1 million to Leonard. All built.